Hey everyone, Professor Adjovan here with another episode in the linear series. This is episode 17, where we're going to look at systems of linear equations, and we're going to look at how to solve them specifically with graphing in this video. So we have three examples that we're going to go through in this video. They're on your screen now. So you need to make sure that you know how to graph linear equations. If you're still unsure with graphing, I recommend going back several episodes and looking at how to graph things in slope-intercept form, standard form, and point and slope form. That will be very helpful and a good thing to know before watching this video. So with that, let's go ahead and jump into it. So the key with solving systems of linear equations with graphing specifically is that you want your graphs to be as precise as possible. The solutions that we are looking for is the intersection of the two lines. So if our lines are a little bit off and they're not exact, we're not going to get a precise intersection, and our solution, our answer, will not be exact. So we want to be very careful as we do this. So let's start looking at these two equations. They're both in slope-intercept form. So we know how to graph things in slope-intercept form. We can take the intercept of -2, and that makes our first point. Our slope is -2, which means I go down 2 and over 1, down 2 and over 1. And if I wanted to go to the left to make this more accurate, I could go left 1, up 2. I could do the opposite. Left 1, up 2, left 1, up 2, and so on. Alright, so I have a bunch of dots. I can go ahead and connect these points. And this makes our first equation. So now we want to plot the second one. Right, it has an intercept of -7, so we start all the way down here. And we go up 3 and over 1, up 3 and over 1, and so on. And we can already probably see where we intersect the line. So let's go ahead and connect these. And right here, the two lines intersect. And what is this point? This point is at 1, -4. So this would be the solution to this linear system. This is where the two lines intersect. All right, let's look at another example. Our first equation is x plus y equals -5. So this is written in standard form. We can graph easily in standard form if we look for the x and y intercepts. I can look at when y is equal to 0 and get x is equal to -5. And I can look at when is x equal to 0 and we get y is equal to -5. Right, that gives us 2 points. So we can go ahead and connect these 2 points. Just like that. And then we can graph our second line. This one is in slope-intercept form again. So we can look at the intercept of -2. That's our first point. And it has a slope of 1/2, meaning we go up 1 over 2, up 1 over 2. And let's go the other way because that's where we're going to be intersecting. So to go the other way, I want to go down 1 and to the left 2, down 1 into the left 2, and so on. And let's go ahead and intersect these. Connect these dots, and we now have a linear equation, and we can look at where these two lines intersect. Alright, and this is why I said that we need to be as precise as possible. If we look at where this intersection is, it's hard to tell what that exact point is. So I'm gonna use my straight edge tool, and I recommend that you'd use your straight edge tool, whether that's the side of a textbook or the side of, an eraser or your notebook, or of course, a ruler if you have one, to make a much better line connecting these 2 points. And then I'll do the same thing with the other one, with the blue line, to make it much more precise. Alright, now let me clean this up a little bit. There we go, that's quite a bit more precise. As we can see, rather than the intersection being in the middle of a bunch of points, it is now nice and precise right on this point right here, which is the point -2, -3. So that really showcases how precise you need to be with your lines to get an accurate answer. So -2, -3 would be our solution. And we have one final example to look at. We have two equations now written in standard form. So we have a couple things that we can do. We can definitely graph these in standard form. Right? We can look at when is y equal to 0. We're going to have 3x is equal to -3. We'll do some side work. And we get x is equal to -1. We can put that one down. And then if we let y or x be equal to 0, we get 2y is equal to -3, or y is equal to -3 halves. -3 halves is -1.5. We can put that right there. Now it's going to be a little difficult to make a very accurate line with just these 2 points. So we can do something. We can look at the difference between these 2 points, kind of the slope between these 2 points. Right, to go from this first red point on the x-axis to the second red point on the y-axis, we go over 1 and down 1.5. So we can continue that pattern. We can go over 1 and down 1.5. We can go over 1 and down 1.5, and over 1 and down 1.5. We can do the same thing the other way. So to the left 1 and up 1.5, to the left 1, up 1.5, and so on. To give us some more points to graph our nice and accurate line, I'm going to cheat and use my straight edge to get a nice straight line. Alright, what about the other equation? Again, it's written in standard form, so let's think about this. When y is equal to 0, we get 2x is equal to -15. Dividing both sides by 2, we're going to get x is equal to -15 halves, or -7.5. And for y, if we let x be equal to 0, we're going to have -3y is equal to -15, which gives us y is equal to +5, right up here. So let's cheat again and grab the straight edge and connect these 2 points so we can get a nice picture of the intersection right here where the 2 lines overlap. This point where they overlap is at -3, 3. So this would be the solution to do this system of linear equations. Alright, so this is the first way to solve a system of linear equations with graphing. There's 2 other ways, which will be the next 2 videos in this series, with substitution and elimination, so be on the lookout for those. If you found this video helpful at all, consider giving it a like and consider subscribing to the channel. Thanks for watching, good luck, and we'll see you in the next one.